Hello guys, welcome to episode 1 of our video series, Math for NDT. Today we're going to be talking about the basic operations of math, and we're also going to be talking a little bit about the language of math. Before we get started, I want to ask you guys a question. I have 2 questions that I'm going to pose here, and I want you to think about them. And hopefully, by the end of the class, I'll be able to answer these questions for you, or help you decide what the answers are. So the first question is, what would it take for you to be good at math? Maybe you're not so great at math. Maybe you are good, and so this might not apply to you, but a lot of us, math doesn't always come easy. Some of us have to work at it. And so what would it take for you to be good at math? Hopefully by the end of this video, you'll be able to answer that. Question number 2, what happens to the near field if a transducer diameter increases? Maybe you've never touched ultrasonics a day in your life. By the end of the video, you're going to be able to answer this question without even having to do any math. Before we get started, I want to talk to you guys about calculators. Now, the choice of a calculator is usually a personal choice. There's several different brands out there. Texas Instrument is one, Casio is another major one, and everybody has a preference. What it comes down to is personal preference. And so when you buy a calculator to use on your exams, what it really comes down to is what you prefer, what works for you, and also what your examiner is going to allow. You know, every examiner is different. If you go take an NAS 410 exam, you really need to talk to your examiner before the exam to find out what they're going to allow. A lot of times they're not going to allow calculators that have advanced memory functions. They won't allow you to have a calculator on your phone. Just make sure you check in with your examiner and find out what you could have. For my students here, this is what I furnish them with. It's the TI-30X2S. It's a really good calculator. I prefer Texas Instruments myself. I like that the Texas Instrument calculators have a pi key, and so you don't have to put 3.14 in when you're computing a number that involves pi. You can just push the pi key. I like to save my rounding for the end. They're just really intuitive and easy to use, so this is personally what I prefer. Now, if you ever go take an AS&T exam, you're going to be furnished with this calculator right here. And actually what you're going to be furnished with is an emulator of this calculator. It's a digital test, and so they give you this digital calculator. And this is the TI-30XS, and it's a pretty good calculator as well. It's very close to the TI-30X2S, which is what I give my students. And so both these are good calculators. You can pick them up, relatively cheap, under 20 bucks. So anyways, this TI-30XS is what I'm going to be using during this video course. So I'll be demonstrating how to use it. I'll be showing you how the functions work. Okay, so we're going to be talking about the language of math. Math is just essentially a language. Okay, it's a language that people developed in order to explain how things work and to be able to solve problems. And so if you understand the language, then you'll be able to understand what the problem is telling you. And so because math is a language and it was developed by people, it's something that any person can understand. All you have to do is really take the time to learn it and figure out what the problem is asking of you, and you'll be able to solve it. No problem. Most people think that in order to be good at math, you have to be good at arithmetic, because that's kind of what they drill into you in elementary school. And I'm here to tell you that's not the case. You do not have to be good at arithmetic to be good at math. It helps, no doubt. But not everybody's good at arithmetic, okay? And these days, honestly, that's what you have calculators for. And so if you understand the math problem and you understand how your calculator functions and how to use it, you're going to be able to do well on these exams, no problem. And so let's get started. First thing we're going to talk about is the 4 basic operations in math, okay? Now, some of this might be a little elementary for some people. If it is, I apologize. I hope you hang in there with me, because I think there's going to be some good information in here that anybody could use. But if this first part's a little too elementary for you, skip ahead if you need to. Okay, and so the first thing we're going to talk about is 4 basic operations in math. All right, you have addition, you have subtraction, you have multiplication, and you have division. And we're going to talk about what each one of these things mean, okay? And so the first thing we have is addition. Okay, addition is simply calculating the total of 2 or more numbers. Okay, it's the sum of something. And this word sum is a key word. All right, so if you're taking an exam, or if you ever hear, if you're ever doing some kind of a word problem and it says find the sum of, that should automatically clue you into the fact that you're getting ready to do addition. Okay, and mathematically, addition is expressed as, A plus B equals C, right? Some quantity, or it could be like, 4 plus 3 equals 7. You're simply just adding two things together. Okay, so the next operation that we have is subtraction. Subtraction is just simply removing things from a group. And so the key word that you hear with subtraction is difference. If you ever hear this word difference, that means you're getting ready to subtract. And mathematically, that's represented with this minus symbol. In math, we have these symbols here. And those symbols are telling us to do something. Now, most people don't have a problem with addition and subtraction. Okay, most people know how to do those things. And it's because we understand the symbols. And as I take you through this, hopefully I'll be able to explain what all these symbols mean well enough to you so that you'll start to understand them. And then you'll start to understand the language of math. And so the subtraction symbol here is essentially just, a word for take away or find the difference. And this plus symbol here is just another word for, give me the total of. Now, addition and subtraction are what we call inverse operations. They're opposites. Okay, and so the opposite of addition, if I took 3 plus 4 equals 7, okay, the opposite of that would be 3 minus 4, taking away 4, right? And so these are what we call inverse operations, or opposite operations. And that's important to know because when we go to solve equations, in order to solve an equation effectively, you have to understand what the inverse operation is. Let's take a look at our calculator. I'm going to start demonstrating how to use it as we go along. So the first thing we did was addition. Okay. One thing I want to point out is with this emulator, it captures my keystrokes in the screen to the right. And so you'll be able to kind of see and follow along with me. If you're not sure what I did, you couldn't see my pointer here, you could always look over here and it'll show you exactly what key I pushed. So the first thing I'm going to show you is addition. 4 plus 4. Now on this calculator, it doesn't have an equal sign, it has an enter key. And so I push enter and I get the answer. Okay, let's take a look at subtraction. It's the same thing. 5 minus 2, and then I push enter. Okay, and that gives me the result. Now, one thing that I need to point out to you guys is that I have this key right here, which is the subtraction symbol. I use that for doing subtraction. Okay, and then I have this key right here, which is the negative key. That's for inputting a negative number. Okay, so the next operation we have is multiplication. All right, and multiplication is essentially just repeated addition. Okay, it's doing addition over and over and over again. So for example, if I have the expression 4 times 3, okay, I could rewrite that as 4 plus 4 plus 4. If we take a look at this equation, 4 times 3, what it's telling us is take the number 4 and add it to itself 3 times. Let's take 6 times 2. It's probably too simplistic, but 6 times 2 we know is 12. And so, 6 times 2 is really the same thing as saying 6 plus 6, which is 12, right? All right, so for example, take the problem, 4 times 4. Okay, again, we know this is 16 because we've memorized our multiplication tables in school. But I could rewrite this, and it's really the same thing as saying 4 plus 4 plus 4 plus 4. 4 plus 4 is 8. 4 plus 4 is 8. 8 plus 8 is 16. So multiplication is just a way to do repeated addition, and it's a way to do it more efficiently. That's why we memorize these tables, so that you don't have to do the repeated addition over and over again. So the next operation that we have is division. You can guess that division is really just repeated subtraction, okay? And so let me show you some examples. Okay, I've drawn this square here to represent a basket of sorts, okay? Just think of it as a basket. And in this basket, you have some eggs. And you can see in this basket, I have 9 eggs. Okay, 3 rows of 3, I have 9 eggs. And I have 3 hungry people here waiting to receive some eggs. Each person wants an egg. Okay, and they're all standing by just waiting for their eggs. And so I want to divide this basket of eggs evenly, and I want to give an even distribution to each person, okay? And so I think you could see that, you know, this guy here is going to get 3 eggs. And this chick here is going to get 3 eggs. And this person here is going to get 3 eggs. Okay, and so each person got 3 eggs. They all got an even distribution of eggs. Essentially what I've done here is I've subtracted the eggs from my basket. Okay, I subtracted 3 eggs from the basket and gave them up to this guy here. I subtracted 3 more eggs from the basket and gave them up to this lady here. And then finally I subtracted the remaining 3 eggs from the basket and gave them to this person here. And so what I had done in this case is I've done subtraction over and over and over. Let's say I had 21 apples, okay, and I wanted to distribute these 21 apples to 7 different people as evenly as I could, okay? And so I started off with 21 apples here, and I told everybody, hey, come take 1 apple from the basket. And so all 7 people come, and they all take an apple. And so the total number of apples taken is 7, but each person got 1 apple. And what I'm left with is 14 apples. And so then I tell everybody, okay, now come take another apple. And so everybody comes to the basket, takes an apple. Each person ends up with 1 apple. But 7 were taken from the basket, and I'm left with 7 remaining. And say, all right, guys, come and get the rest of the apples. And so the rest of the guys come and get the apples. And now I have no more apples left, and each person got 1 more apple each. And so at the end of the day, everybody has a total of 3 apples each. And so essentially what I've done here is repeated subtraction over and over and over until everybody got an even distribution of apples. Now, mathematically, I could represent this by saying 21 divided by 7 equals 3. This is the mathematical way of representing what I just did here. So just as addition and subtraction are inverse operations, multiplication and division are inverse operation. And so the opposite of multiplication is division, and the opposite of division is multiplication. Multiplication and division, you would use these keys here, and you would enter it the same way you did with subtraction and addition. There's just some differences I wanted to show you. Let's say I want to do 9 times 9, right? You could do it the traditional way, 9 times 9, hit enter, and get 81. I could also put a 9 in a bracket, and then put another 9 right there, and hit enter and get 81, because here it's doing implied multiplication, right? I didn't need a symbol. You could also, say like 9 in a bracket and put another 9 in a bracket, and it's still going to do implied multiplication. Okay, and so the next operation that we have is exponents. And when you see an exponent, it's going to be in this form. Okay, some number raised to a power. We call this the power of. And so, for example, let's say I have 3 to the 3rd, okay? And so what exponents are is repeated multiplication. Okay, essentially what we're doing is we're doing a multiplication over and over and over again. And so when you see something like this, what it's telling you is take the number 3 and multiply by itself 3 times, okay? And so this problem here, I could rewrite that as 3 times 3 times 3. Okay, and so 3 and 3 are 9. and then 9 and 3 are 27. And so 3 to the third power is 27. Let's look at another example, okay? I have 5 to the third power. Okay, that equals 5 times 5 times 5, because we're doing repeated multiplication. 5 times 5 is 25, times 5 more is 125. And so 5 times 5 times 5 equals 125. The next operation we have is square roots. Okay, this could be a tricky one to wrap your mind around, but it's actually pretty simple. Okay, a square root is represented by this radical symbol, and there'll be some number in there. Okay, and so what this square root radical bracket symbol means, what it's telling you is it's saying what number multiplied by itself equals the number that's inside. Okay, what number multiplied by itself equals the number that's inside. So let's say I had the square root of 4. What number multiplied by itself equals the number inside? Well, I think we could see it's 2. 2 times 2 equals 4, right? And so the square root of 4 is 2. All right, let's try another example. What about the square root of 25? What number multiplied by itself equals the number inside? There's no wrong way to do this. You could start with 2, right? 2 times 2 equals 4. Nope, it's not that. 3 times 3 equals 9. Nope, it's not 3. 4 times 4 equals 16. Nope, it's not 16. 5 times 5 equals 25. Yep, that's the right answer. And so the square root of 25 is 5. So what about the square root of 7? What's the square root of 7? And so 2 times 2 is 4. So I know it's not 2. 3 times 3 is 9. It's not 9 either. But I could see here that the answer probably lies between 2 and 3. And so you could kind of estimate square roots. All right, there's ways to calculate this with pencil and paper, but this isn't something I'm going to go over in this course. And honestly, nobody really does that. That's what you have calculators for these days. And so when we get to the calculator portion of this lesson, I'll show you how to do square roots. Exponents and square roots are also inverse operations. The opposite of taking an exponent would be the square root, and vice versa. So far we've looked at the following operations. We've looked at addition, which is basically combining things, and the key word for addition was the sum of. We talked about subtraction, which was removing things from a group, and the key word for subtraction was the difference of. We looked at multiplication, which is just repeated addition, and I forgot to mention this, but the key word for multiplication is product. If you're doing a word problem and it tells you to find the product of something, that's letting you know you need to multiply. We talked about division, which is essentially repeated subtraction. And I also forgot to mention that the key word that you hear with this a lot when you're doing your word problems is quotient. Okay? We also talked about exponents, which is repeated multiplication. And we've talked about square roots. And so what I hope that you are starting to recognize is that each one of these symbols is essentially just a way of communicating to you. They're almost like words. They have a meaning, and they're trying to convey an idea to you, just like the word dog. It's a word that has a meaning. When I speak it to you, there's a picture that comes into your mind. You understand what I'm trying to tell you when I say dog. It's the same thing with these symbols in math. They're trying to convey an idea to you. Let's take a look at some other symbols that are used in math. You have the equal sign. And what this means is two things are equal to each other. They're the same. Okay, so for example, A equals B. I don't know what the value of A is here, and I don't know what the value of B is here, but I know that they're equal to each other. And so whatever A is, B has to be as well. And so, for example, if I told you A equals 5, okay, then you know that B also has to be equal to 5. Okay, B can't be anything else. It has to be 5. Then you also have this symbol here called the inequality symbol, which essentially means that two things are not equal to each other. So, for example, I could write the statement 7 does not equal 8. Okay, these two things are not equal, and so this is a true statement. You have this symbol here, these two little squiggly lines that mean something is approximately equal to something else. Okay, and so for example, I could say pi is approximately equal to 3.14. Now, if I took if I took the ratio of pi and stuck it in my calculator, it's actually a lot longer than 3.14. Okay, and it goes on forever. So I couldn't say pi equals 3.14 because that's not a true statement. And I couldn't really say pi does not equal 3.14 because that's not exactly true either, although this is more true than this. And so the best way to write this is here, because pi is approximately 3.14. It's good to use these numbers, whenever you're estimating something. For example, let's say, you're out in the field and you're doing an inspection and you find a crack, okay? And maybe it's in a tight spot and you measure it the best you can from tip to tip, okay? But you're not really confident in your measurement. Nothing's always perfect, right? And so, let's say you measured this at, 1.25 inches. And so on your report, you might want to say, the crack was approximately 1.25 inches. Okay, so let's take a look at this equation here. This is the equation for speed equals distance over time. This is something that you use in ultrasonics a lot. And so what this is telling us, we're learning to speak the language here. And so what this is telling us, if you want to find the speed of something, what you have to do is divide distance that you traveled and the time that it took you to travel it. Those two things are equal. They're the same. The speed is the same as the distance you covered and the time that it took you to cover it. They're equal. And in math, there's a special word that we use to describe equality. We call it being proportional. So I want to show you two different scenarios to illustrate a point. In scenario 1, I'm going to travel 1 mile, and it's going to take me 1 hour. And in scenario 2, I'm going to travel 2 miles, and it's going to take me 1 hour. Okay, and so you could see that in both scenarios, the time stays the same. It doesn't change. Okay, the only thing that changes is the amount of time it took me to travel. Scenario 1, I'm going to say speed equals distance over time. And so speed equals 1 mile per 1 hour. And so my speed is essentially 1 mile per hour. Now let's take a look at scenario 2. Same thing. Speed equals distance over time. But this time, I traveled 2 miles, and it took me 1 hour. And so my speed in this scenario was 2 miles per hour. And so what am I trying to show you here? What I'm trying to show you is a very, very important concept in math. All things stayed the same in both scenarios, with the exception of my distance. Here I traveled 1 mile, here I traveled 2 miles. Okay, and so in this example, I traveled 1 mile per hour, and in this example, I traveled 2 miles per hour. And so what you could see from this example is that when my distance goes up, my speed also increases, and vice versa. These two things are what we call directly proportional. Okay, when one goes up, the other goes up. And so when you understand the language of math, you don't actually have to crunch any numbers to understand that there's a relationship in this formula. For example, if I gave you a test question and I said, what would happen to your speed if your distance went up but your time remained the same? You should be able to just look at this question and know that your speed is going to increase. So let's look at two more scenarios. So in scenario 1, my distance is going to be 1 mile. And it's also going to be 1 mile in scenario 2. Okay, that's going to kind of be my constant. And in scenario 1, my time is going to be 1 hour. And in scenario 2, my time is going to be 2 hours. Okay? And so speed equals distance over time. Okay, my distance was 1 mile per 1 hour. And so my speed was 1 mile per hour in scenario 1. Okay, so let's look at scenario 2. Speed equals distance over time. And I traveled 1 mile. It took me 2 hours. And so my speed was a half of mile per hour. And so what we could see in the second scenario is that when our time increased, our speed actually decreased. And so when this increased, our speed actually decreases, and vice versa. And that's because these two things are what we call inversely proportional, or they're opposite. Okay, anything on the bottom of the division, when division is being done, anything on the bottom of the fraction is inversely proportional to your variable. And so if I asked you what would happen to your speed, if you traveled the same amount of distance but your time increased, you should be able to just look at this equation without doing any math at all and see that your speed will decrease. And that's really the beauty of math. That's why understanding the math is so important, especially on NDT exams, because there are times where you may not know the answer, okay, but a lot of times they furnish you with the equations. You can just go back at the equation and figure the answer out for yourself. I've done it a lot of times. There's a lot of times I've had a question and I'm not sure what the answer is, and I just go look at the equation. And because I understand the language of math, it starts to make sense to me, and I'll be able to answer that with no problem. So let's take a look at one of these questions that I asked you at the very beginning of the video. What happens to the near field if the transducer diameter increases? Okay, now take a look at this equation. This is equation for near field used in ultrasonics. And you don't have to be trained in ultrasonics to be able to answer this question. And you don't have to do any math at all. And that's the beauty of math and understanding equations. And so I want to know what happens to the near field if my transducer diameter increases. And we're assuming all other things stay the same, right? And so you could already see that these two things are directly proportional. And so my near field is going to increase in length. And so I hope you could see the value in understanding the math and understanding what the equation is telling you. This is something that's really going to help improve your test scores. The next thing we're going to talk about is decimals. The word deci means tens, right? And so let's take, for example, fraction 3/4. 3/4 in fraction form, when you're looking at this fraction, what it's telling you is you have 3 parts of 4. So your number system essentially is based on 4s. If I stuck this in a calculator and did 3 divided by 4, it would give me 0.75. This is based on power of tens. And so a decimal is basically just a number that's based in the power of tens. For example, 0.75 is really the same thing as saying 75 over 100. Let's look at the fraction 3/8. My number system is based on 8s, right? And so I have 3 parts of 8. If I stick this in my calculator and do the division, I get 0.375, okay, which is based off the power of tens. All right, and another way I could write this in fraction form is 375 over 1,000. All these things mean the same thing. They're all the same number. They're just different ways of writing them. Let's go back to exponents for a minute. Okay, we already talked about exponents. We understand what they mean. All right, exponents are just simply repeated multiplication. And so one thing I want to show you is that sometimes an exponent could be expressed like this, a to some power, like, 2 squared. And sometimes you see what's called this little caret symbol, like that. You see them on calculators. That's just a form of saying, do this exponent. So for example, you may see 2 caret 2. All right, and what that means is 2 to the second power. They're the same thing. So we have already explained what square roots were. This radical is essentially telling you what multiplied by itself equals the number inside, right? And so what I need to explain to you is, in all actuality, the correct way to write this is a little 2 on the outside. Now, square roots are so common, they often just leave the 2 off, and it's understood, it's implied that you're doing a square root right here because there's no symbol on the outside. However, you could actually have other numbers out here. And so this is what we call the cubed root. And so for example, let's say I had the cubed root of 8. What this is asking me is what multiplied by itself 3 times equals 8. And so the correct answer here would be 2, because 2 times 2 is 4, and then multiplied by 2 again is 8. You could also have a 4th root, and in all actuality, this number could be anything. And so for the 4th root, let's say I had what is the 4th root of 16? That's asking me what multiplied by itself 4 times equals 16. And so the answer here again is 2, because 2 times 2 is 4, times 2 is 8, and times 2 is 16. Exponents, there's a couple of different ways to do this. All right, let's say I just want to square something. So let's say I want to figure out what 5 squared is. I push 5 and the x squared button, hit enter, and I get the result. And so this button here is just a quick way to square things if all you're doing is squaring. 9 squared, enter, I get the result. Now, I also have this caret symbol, and you'll remember from the lesson that the caret symbol denotes that you're going to do an exponent. And so if, let's say I wanted to do something to the power of 3, right? I obviously could not use the square symbol. And so let's say I want to figure out what 5 to the power of 3 is. I would use that caret symbol and hit enter, and I get the result. All right, let's take a look at square roots on the calculator. Now, if I want to do a square root, I have the square root key right here, and it's a shared key. It's shared with the squared button, okay? And so in order for me to access this button here, the square root button, I have to push the second key. The second key is for any of these we call them second functions, and they're in green, okay? Let's say I want to figure out the square root of 25. I push second, and then I push the x squared key because the second function is the square, and then 25, and I hit enter, and I get the result. Now you'll notice here when I push enter, it put a little parenthesis here, and I didn't close the parenthesis, okay? If all you're doing is this one function and nothing else, you don't have to close that parenthesis, okay? But if there's other math involved, like let's say I'm going to add something to this, then you would want to close your parenthesis. In truth, it's probably a good idea just to get into the habit of doing that, okay? And so what you want to do is you want to push second square root 25 and then close your parenthesis. Hit enter and it gives you the result. Let's do the square root of 7, okay? You'll remember from the example earlier, we tried to figure out what the square root of 7 is, and it wasn't an even number, right? The best we could figure out it was between 2 and 3. And so we're going to use our calculator for that. So second square root 7, close the parenthesis, push enter, and the answer is 2.64 and some change. What if I wanted to do a cubed root? All right, here I have the nth root symbol. And so you can see this little x here. And I can put any value that I want in for x, okay? I'm going to try to find the cubed root of 27, okay? And so I pushed 3, second, the nth root key, and 27, hit enter, and I get the result. We have percentages in math. And basically what a percentage is, it's essentially a part per 100. One thing I forgot to mention when we were talking about division, whenever you hear this word per, that should clue you into the fact that you're getting ready to do division. So for example, if somebody said how many miles per hour did you travel, if you looked at what a mile per hour is it's actually miles divided by hour, right? You're doing some division here. If you're trying to measure the flow rate out of your garden hose, you would measure that in gallons per minute. And what I'm doing is I'm dividing the number of gallons that come out of the hose by the minutes it took those gallons to come out. And so anytime you hear the word per, think division. So let's take a look at an example of a percentage. Let's say you took your NAS 410 basic exam and you did really good. You got 36 out of 40. And so you're pretty stoked about that. You know you passed, but you want to know what your percentage is. So you stick this in your calculator, 36 divided by 40, and it spits out 0.9. And so we multiply it times 100 because a percentage is a part per 100, and you get 90%. Okay, I'm going to show you how to convert fractions into percentages on your calculator. From the example before, we were trying to figure out our percentage on an exam. Okay, and so let's say I took the specific exam and I scored, let's just say 31 points out of 35. Hit enter. Okay, now remember, a percentage is a part per 100. And so to figure out the percentage, all you have to do is multiply this by 100. Hit enter, and you get the result, 88.57%. And so there's another way to figure out percentages using this calculator. To me, it's a little gimmicky, but it's part of the calculator, so I'll go ahead and show it to you. If you like it, use the function. If not, don't worry about it. But let's say I had a decimal, 0.02, right? And I wanted to turn that into a percentage. Well, you could push the second key here, and then you have this little percentage second function here, and you hit that, and you hit enter, and it converts it into a percentage for you. Some other common symbols that you see in math is you see what's called the less than symbol, okay, which means A is less than B. All right, and so for example, I could write 3 is less than 4, right? And that's a true statement. You could say that A is greater than B. Okay, and so in this case, I would write 4 is greater than 3, and that's a true statement. I'm sure you remember this from elementary school. They teach you the little alligator symbol, right? This is like essentially an alligator mouth, and the alligator is a hungry dude, so he's always going towards the bigger number. And so if I had the number 10 here and the number 5 here, the alligator would want to gobble up the 10 first because it's bigger. Okay, if I put a little line underneath my symbol here, what that means is greater than or equal to. And so this line here means equal to. And so for example, you might say x is greater than or equal to 5. And then so when you start to try to figure out what the value of x is, let's say I start making a list, well, x could be 5 because it's greater than or equal to 5. It could be 5.1, it could be 5.2, it could be 6, it could be 7, it could be anything greater than 5 because it's greater than or equal to 5. Now, if I took this symbol off here, now x could not be 5, right? Because it says x is greater than 5, and so I would get rid of my 5 here. In math, you'll see parentheses and you'll see brackets. And these are just symbols that tell you do this first. And so for example, let's say I had a problem 5 plus 2 times 3 plus 9. Okay, and so what this parenthesis is telling us is, hey, do this part first and then do this part. Sometimes you see the symbol plus or minus. And what this is telling us is to do both operations at once. And so for example, you see this a lot in tolerances, right? Okay, let's say, I had, some kind of part being fabricated like a bar or something, and it had some sort of dimension here. Let's just say it was 1 inch. and then the tolerance was plus or minus 0.1 inches. And so what that's telling us is to do both operations at once. And so the value of the length of this bar could be 1.1 inch, or it could be 0.9 inch, or it could be anything in between these two numbers. I want to go back to multiplication for a minute. Okay, everybody knows this symbol here. When you see this symbol here, you know, hey, I'm going to do some multiplication, right? But multiplication could be expressed using a variety of different symbols. Okay, and so you have the classic multiplication symbol, a times b. Okay, that could also be written with a little dot here, a times b. Okay, it means the same thing. Then you also have something called implied multiplication. So if I have a and b together with no symbol at all, in algebra it's implied that you're doing multiplication. Okay, and that's just a shorter way of doing it so that you don't have to write the symbols over and over again. So for example, I could say 5 times 3. I could say 5 dot 3. Okay, and I could also put this 5 in a bracket and then 3 next to it. And it's implied that those are being multiplied. Okay, the term 6x, I don't know the value of x, and I don't have to know what that is. But I understand that these two things are being multiplied. Likewise, there's a number of ways that division is represented. Okay, you have the division symbol, 6 divided by 3. Okay, it could be shown with a slash, kind of like a 6 divided by 3, right? It could be expressed as a fraction, 6 divided by 3. Same thing. And remember, if you hear the word per, you're doing division. Okay, and then it could also be used by using like the long division bracket. Okay, in this case, it would be 6 and 3 there. For most of you, this would probably just be a good recap. I just want to do a quick review of what we talked about. And so we talked about basically the language of math and what everything means. We talked about addition, talked about subtraction, and the result of addition is the sum. The result of subtraction is the difference. We talked about multiplication. The result of multiplication is the product. And we talked about division. The result of division is the quotient. Another key word I want you to listen for is the word per, which also denotes the fact that you're going to do division. We talked about how these two things are inverse operation and how multiplication and division are inverse operations. We talked about how multiplication is just essentially repeated addition and how division is just essentially repeated subtraction. We talked about square roots and how they're essentially just repeated addition. Exponents and how they're essentially just repeated multiplication. Square roots and how essentially it's just asking you to find a number that when multiplied by itself equals the number inside. We talked about how these two operations are inverse operations. We took a look at equations and we understood what it meant by saying two things are equal and what proportional means and what inversely proportional mean. And so we know that anything on top of the division symbol is proportional to this variable, and we know anything on the bottom of the division symbol is inversely proportional to this symbol. Okay, we looked at decimals, and we understand now that a decimal is just a number that's based off a power of 10. And then we just looked at some of the different symbols that you see in math and what they mean. Caret symbol is the same thing as denoting an exponent. You could have a square root, but you could also have roots to other powers, like you could have a cubed root. Talked about what a percentage was, and it's essentially a part per 100. We looked at the different quality symbols that you would see in math. We looked at the different multiplication symbols that you find. And we looked at some of the different division symbols that you find. So guys, that's all I have for you right now. Some of it's elementary, but even if you're relatively good at math, I think sometimes just kind of reviewing and taking a look at the different terms and what they mean is helpful. I've already answered question number 2 here, and you were able to answer that even if you've never done ultrasonics in your life, which is awesome. And so that's a skill that I hope you keep and develop, because it's really going to help you in your exams, being able to look at equations and understand the relationships between two things. And so let's take a look at this first question. I asked, what would it take for you to be good at math? Really, this is kind of a personal question. This is something that's different for everybody. But what I would suggest is that in order for you to be good at math, you have to understand the language and what it's saying to you. And if you understand the rules and the language and the order in which you have to do things, then you could be good at math. And there's a second part to this, which I didn't mention, repetition. In order to be good at math, you have to work problems over and over and over again until you're sick of them. All right, well, thanks for joining me, guys. Take care.